Hello, my name is Salman and this is my contribution. So at the beginning was the noise calibration. So the robot doesn't listen to the background noises. So the beginning was the Celera VAD listens to the room and measures how loud the room is. So using that average energy, it creates a safety buffer. So the threshold can differentiate between the background noises and the speech. So it waits a couple of seconds so it doesn't cut you off. Then it takes the speech, which is the energy above the threshold. Then it waits until it goes back down, which means the person has stopped speaking. It records, then sends it to whisper. And in case of anything, it stops by its own, so it doesn't keep going and listening. After the robot's text to speech, it gets sent back to OpenAI. Then OpenAI comes back with the replies. However, the replies come back as one block with no structure, so the code over here splits it using full stops and marks, and it handles new lines in case replies has line breaks. And if it cannot split it, then it just sends it back as one sentence, and sends all the sentences using SSH instead of one call per sentence. After a session is played, save the score, the best streak and difficulty to adapt to either go easier or harder, and which games have been played so it doesn't repeat. And once we restart, it checks if there is any sessions have been played and rebuilds the engine based on it. So it says the score streak, difficulty, and game type to where it was. Unless the user says start fresh, then it deletes and start fresh again. After a question gets answered, it goes through OpenAI to detect whether the answer is correct or wrong, and so it turns it back to the robot. And here's an example of a wrong answer.
Try. It is 89, so it's not quite there. You were very close with the 25 and 6 times 9 part. Want to try once more?
The robot has different LED colors, and each color represents a state, and it has different gestures where it waves its hand. So at the beginning where it starts, for example, over here, it waves its hand, and when you get a correct answer, it also waves. My last contribution is the testings, and as you can see here, we have a full test of the project.
Nicely done. Would you like another number, son?
Let's play another game. Let's play another numbers game.
As you can see, the facial detection, and the state is uncomfortable, so the robot's eyes color was blue.
Lovely. Here's another easy one. Use 25 and 3 to make 75.
The answer is 25 times by 3.
As you can see, it's detected that the answer is correct.
Exactly right. 25 times 3 is 75. You're doing really well. Shall I make the next one a little trickier?
Make the next one trickier.
As you can see, the wave, after it takes a correct answer, is a kind of a celebration. As you can see here, the multi-signal state inverse was tested to show the different states, and they refresh in every single session. And as you can see here, what happens after a correct answer.
Yes, that's right. Well done. You reached 352 nicely. Would you like another numbers 1 or letters round?
As a way of guidance to help the user.
Gaze's novel contribution is a multi-signal adaptive cognitive loop, where it will first infer the state, adapt, and then evaluate if the adaptation actually helped. So the architecture was finalized as a hybrid one, where perception and inference run on the computer, and then Pepper handles the output, text-to-speech, gestures, and LEDs. Pepper's mic was so bad it would just succumb to the noise, which would cause whisper hallucinations that are blacklisted, and its count streams is roughly just 10 frames per second, whereas the local one is 30 FPS. So the brain sits where the signals are clean to get. So the first offense, the Cyro FAD, it uses relaxed defaults for to get short answers, such as yes or no. Then also, Whisper's own no-speech probability, so if Whisper itself flags it as silence, then we just drop the transcription. Then this function that checks if the input is likely a hallucination, and if so, it will drop it. Despite this being frozen, like that is, I can't train it anymore, what makes it adaptive is this function, because each time the live signals block is rebuilt from the face, voice, volume, response time, and rolling quickness, and hence each time's prompt is dynamically adjusted based on these updating signals. It's basically just prompt engineered, as the symbolic engine describes the user to ChatGPT in plain text, and then it writes ChatGPT writes a reply based on that description. So it is neurosymbolic in the literal sense, as the symbolic part is how it reads the user, and the neural part is how it talks back. And the pacing label turns the budget into words such as like relaxed or brisk. So then the model just won't parrot numbers back to the user. So this function called evaluate last adaptation basically evaluates if the previous adaptation worked, and the GPT reads this, it reads the description, so it knows when to use it. So adaptive engine, the brain of the robot, where there's 4 methods that perceive, decide, pace, and evaluate each time. So the infer state method, which uses 6 signals to infer 5 different states, which could be thriving, disengaged, frustrated, struggling, or if it doesn't really know, it would be more of a neutral, comfortable version. So then this bit, it checks in 2 ways. Once just a correctness through the GPT verifier, and then once through the is silent check, which treats any of these skip phrases like I don't know, as disengagement. So it's like it's not wrong, but they're disengaged. And by the way, this function is the GPT verifier for checking if it's correct. Face is the primary signal, and the voice is only consulted when the face reads as a neutral and the vocal confidence is above 0.9. Like that is, it's too noisy or it's too quiet. And then rolling correctness, which checks within 5 most recent rounds how correct they're being. Then second, decide turns infer state into a policy. So like if the user's thriving, then it will like escalate difficulty. If they are struggling, it will ease off. If they're disengaged, it will change it. It will change the game type. Then the recommend think budget function, which just basically lengthens these things. So like say if the user is struggling, then it will then give 8 seconds of time which they can be silent for before the robot does something. Alright, so for example, like if there's no history, I mean like the user hasn't played the game yet, then for like stroke recovery, it will give them 7 seconds before it starts pestering them. And finally for the evaluation, so it first checks the previous state they were in and the current state they were in, and like if they were disengaged in a previous state, but now the current state is they're not disengaged, then it means that they've been re-engaged. Without this function, the robot would adapt blindly.